two scenarios. We'll approach each scenario separately. So for part A, we have a skier mass. We have the forced normal. This would essentially be the normal force exerted by the water on the skier. And then here we have mg. To the right, we'll have a force applied. And this is simply we actually will have force tension. This is the rope connected to the skier that is connected to the boat that is pulling the skier. And then this is perfectly, in part A, this is perfectly horizontal. And then we can say back here, force friction, always opposite of motion. We have the mass of the skier, 72 kilograms, and we can say that sigma F in the y direction equals 0 newtons. Therefore, the normal force equals mg. Now, we can say that sigma F in the x direction equals force of tension minus force of friction. So we can say, and this equals ma sub x. So we can say that ma sub x equals force of tension minus mu k f of n. Here f of n equals mg. So we can say that force of friction will equal the coefficient of kinetic friction times mass times gravity. And then we simply solve for a sub x. So a sub x equals force tension minus mu k mg, and then divided by the mass. So we can say that a sub x is going to be equal to 240 minus 0.25 times 72 times 9.8, all divided by the mass of 72. And we know that the acceleration is now 0.883 meters per second squared. So this would be the acceleration if the force tension was perfectly horizontal to the x-axis, so perfectly parallel with the x-axis, and not at an angle. So part B is where it's at an angle. So part B, we have a mass Fn, force of friction always opposite of motion, mg always straight down, and then here we have force tension, but it's at an angle theta. So here we can say, first of all, the y direction is not changed. The y direction now is changing because of force tension. So in order to solve for the force normal, it's going to be sigma F in the y direction equals, it still equals 0 because we're not moving up or down, we're only moving left to right. But this will equal force normal now minus mg minus, or rather plus force tension sine of theta. So we can say that force normal is going to be equal to mg minus force tension sine of theta, which makes sense because if it's being applied, and if the force tension is being applied at an angle, it will alleviate essentially some of the force normal, because it'll essentially lift the person up a little bit. So the force normal exerted by the water on the person won't be as much, because again, force tension is essentially alleviating this a bit. And so sigma F in the x direction equals ma in the x direction, and this equals force tension cosine of theta minus force of friction. And we know that the force of friction equals mu k f of n, or in this case, mg minus force of tension sine of theta. And we're trying to find a sub x. So a sub x will then equal force tension cosine of theta minus mu k mg minus force tension sine of theta, all divided by the mass. So we can plug this in. So it would be 240 cosine of 12 degrees minus 0.25, and then the mass of 72 times 9.8, 72 times 9.8 minus force tension, so 240 sine of 12 degrees, all divided by the mass of 72. And we have that the acceleration in the x direction is going to be 0.98 meters per second squared. So this will be our final answer. Notice how this answer is greater than this answer, even though all of the force tension was in the x direction here, and here the force tension was applied at an angle. So why exactly would this acceleration be greater if not all of it is in the x direction? And that is because the force of friction depends on the normal force, and if the normal force is decreased, that means that the force of friction isn't so great, which means that the force tension is able to pull the skier at a faster pace, essentially. That is the end of the solution. Thank you for watching.